Okay students, now we are continuing the pseudo force problems. Suppose let's take there is an elevator, and an elevator, a man is standing. A man is standing. The mass of the man is m, and the elevator is moving upwards with acceleration a. Find normal reaction from ground. Normal reaction from ground. Sorry, from the ground of elevator. Okay. When we solve, now see, this is an initial frame of reference or non-inertial frame of reference. It's a non-inertial frame of reference. So we can solve this problem by two ways. One person is standing on the ground and another one is standing frame of reference with elevator. In these two cases, this case, when the person is standing on the ground, the man appears to be moving upwards. But when the reference is from the elevator, man appears to be at rest. Let's calculate from the elevator point of view. Frame of reference as elevator. Remember, the pseudo force acts based on the frame of reference only. Now this is a mass, capital M, mass of man is m. What are the contact forces? Contact force is normal, and non-contact force is mg. And with what frame of reference we considered elevator? Now, is it elevator is in rest position? No. Elevator is moving upwards. If the elevator is moving upwards, pseudo force act on the man in which direction? As we discussed earlier, pseudo force act in the downward direction. And how much its value? Mass of man multiplied with the acceleration of elevator. Now what is the acceleration from the elevator point of view? Acceleration is equal to 0. Now normal is equal to m into a plus g. Let's do one more example. Now the same man standing in the elevator, this elevator is moving down with acceleration a. Find normal from the foot of elevator. Now again we are considering frame of reference as elevator is our frame of reference. Elevator. This is a non-inertial frame of reference. Okay. When non-inertial frame of reference we consider, then the pseudo force acts. The mass of man is m. Let's calculate the forces. Normal, and there is an unknown force mg. Now because we considered elevator as a frame of reference, there will be elevator is inertial or non-inertial frame of reference? Non-inertial frame of reference. What will act there? Pseudo force will act. In which direction pseudo force will act? Pseudo force will act opposite to the acceleration, and it acts in which direction? Upwards, because acceleration in the downward direction. What is the magnitude of it? Mass of man into acceleration of elevator. Now acceleration with the frame of reference of elevator is equal to 0. N plus capital mg is equal to capital okay, wait a minute. N plus capital ma is equal to mg. N is equal to m into a minus g. Now if acceleration is equal to g, if this is a freely falling body, then normal becomes 0. Okay, these are the simple cases. Let me create a few pages. Okay. Now one of the important and useful problem. This is an angle theta. there is a mass of m, small m, mass of capital M. Okay, this is a frictionless surface. We'll consider two cases, frictionless and with friction also. They all are placed on a frictionless surface. All the surfaces are frictionless. How much force F should be applied such that the block M is at rest with respect to wedge? This is called block, this is called block, this is called wedge. Okay, with respect to wedge, block is rest. Find F. F is equal to how much? So that the block will be at rest. Okay, let's calculate. What is the frame of reference? Frame of reference is wedge. Wedge is a stationary or move with acceleration. It is move with acceleration. Why we are saying it move with acceleration? Because there is a force. If the force is there, there must be acceleration. Let's consider now, when we consider two blocks as single system, if I consider two blocks as single system, what will happen? Capital M plus small m, there is a force. Are there any opposing forces? Let's say acceleration A in this direction. Are there any opposing forces? No, this is frictionless surface, everything, there is a normal, nothing, everything will be there, and F is equal to capital M plus small m multiplied with A. A is equal to F over capital M plus small m. A is equal to capital F over capital M plus small m. Now, this is the acceleration of whom? Acceleration of capital M and small m as well. If we consider the wedge as a frame of reference, wedge as a frame of reference, horizontally it moves. There is a possibility that this wedge can move downwards in this way. This block can move in this way, right? We should prevent this motion also. How we should prevent? Now, if we consider the wedge as a frame of reference or frame of reference, listen attentively. What are the forces acting on small m? Small m, the force is mg sine theta, and there is a, in this direction, mg cos theta, and there is a normal, and what else will be there? Now the wedge is moving with acceleration A in this direction. There will be pseudo force, because we are considering which frame of reference? Wedge as a frame of reference. In which direction the pseudo force will act? Pseudo force will act exactly opposite direction. Opposite direction, this is a pseudo force, exact opposite direction. Acceleration is in this direction, pseudo force will be in the backward direction. And what is its value? Mass multiplied with the acceleration. Now, how much is the angle here? Theta. With wedge, it should be at rest or it should move? It is at the rest. So let's resolve into components. This is a block.
Charge here.
Block and mg sine theta, and in the opposite direction, okay, this is mg cos theta. Now it was ma. I am resolving into components. It becomes ma cos theta and ma sin theta. There is a normal n. if you solve, horizontally it is equal to 0, acceleration vertically also it should be equal to 0. N must be equal to m a sin theta plus g cos theta, because acceleration is equal to 0, and I'm considering this direction. Okay, and next mg sin theta is equal to ma cos theta. M gets cancelled, a is equal to g tan theta. If a is equal to g tan theta, then the body doesn't move. And the question here, it's asked like, what is the force value? Force is equal to ma, right? Capital M plus small m. A is equal to g tan theta. With this force, the block will